So we'll see why it's called connecting the dots. So before we get started, some protocol for today's session. Uh, I think none of you used your mobile phones in the previous talk, so I expect the same here. And usually I use the sleep scale. So it's 1 to 5. You will see the sleep scale appear now and then during the session. Okay, 1 is actively listening. 2 is on and off. It's been a long day. You have had a long commute here and then you are listening on and off. 3 is when will this session end because I can go to dinner. I'm hungry. 4th is probably next week is Diwali. I need to do a lot of purchases, a lot of things are there, and you are talking on clean architecture before Diwali. So please bear with me. 5th is you are somewhere out of the Milky Way. Right? You are I made you sleep. Right? Nice lullaby. So expect some turbulence. Put your seatbelts on because we are going to cover a range of topics. It's going to be a little bit difficult. If some of you don't know something, then probably this is a reference, right? This is a triangle of knowledge. There are things, yeah, I can zoom in a bit. There are things, the stuff that you know and you know, right? Let's say you are a Java developer or a .NET developer, you know the Java and .NET, things like that. There are things that you know, you don't know, which is, in the previous session, they spoke about a lot of things on GenAI. Now you know that something exists, some tool like Eraser.io exists for architecture diagrams, but you don't know what it is. You need to go and explore, right? So there are some things that are going to be like that in this session as well, which you need to go and explore on your own. And finally, the stuff you don't know, you don't know. You don't even know that existed, you don't know it. Now, there are some things in life which will always remain in the second quadrant. Say, for example, you know, but you don't know. Chinese. You need to have a lot of effort, you need to put a lot of effort to learn it. Otherwise, it always remains there. So the nice place to start is here, where you know something like that exists, but you want to understand what it is. So clean architecture, for some of you, you might know it. It might be here. For some of you, it might be here. For some of you, it might be here, right? So we'll try to see how to get everybody here, okay? So that is about the triangle of knowledge. So to start with, everybody, I mean, we are writing code, we are developers, we use GenAI, everything. But why are we going to use it? There should be some kind of a business problem to solve, right? If you don't have a business problem, who are you writing code for? Who is going to pay your salary? Ultimately, the software that you create should get benefited for someone, like it should be beneficial for someone, be it a corporate or individual, B2C, B2B, however the business is, right? And this business as such, either they provide products or services, right? And can I have a quick show of hands? How many of you know domain-driven design? Okay, 1, 2, 3, okay, 4, 5. Heard about it? I don't know, but I've heard about domain-driven design. Okay, a lot more hands. That's fine, good. You don't need to be an expert, right? But there are some things in this slide that you will hear for the first time. You try to go and explore on your own, because we don't, all of these things that you see today in different diagrams is a session on its own or a workshop on its own. We are trying to condense everything and try to give an introduction so that you can go and explore on your own, right? So the first thing, I mean, why are you even talking about strategic domain-driven design? And you told me the title of the talk is Clean Architecture, Connecting the Dots. This is one of the dots, right? Strategic domain-driven design is all about understanding your business. What's your core business problem that you're trying to solve? There are some things that are core, there are some things that are supporting, there are some things that are generic. We'll see what it is. How many of you use Uber, Ola, kind of ride app? Everybody, almost everybody, right? What's the core business problem or the core domain of Uber? Yes. So transportation, trying to find the rider for the given passenger, finding the shortest route, and how quickly you can map a driver to a passenger, because the passenger will have a bad experience if you take more 1 hour something to do it. That is the core business problem that Uber is trying to solve. Likewise, in each of your projects, you will have a core business problem. That's your core domain, right? From a strategical standpoint, that's your core domain. What's a generic domain? No, the core domain is something that offers you a strategic advantage, right? So this is the place where you need to employ clean architecture, meaning There are, again, don't confuse this with architectural styles and architectural patterns. There are architectural patterns, there are architectural styles. Architectural styles, does anyone want to take a hit? Like, what's an architectural style? Some examples. MVC. Okay, MVC is more of a framework, more of a UI thing. I mean, a model view control is more of a gluing thing, right? More from a presentation standpoint or an API standpoint. That's good. But again, microservices. That's an architectural style. Space-based, right? Monolith. And then you have event-driven. All of these are architectural styles, right? But within each of these architectural style, you will employ certain architectural patterns to design the application, architecture your application, put the code together and everything together, right? I see nightmare in everybody's face. It's pretty simple, right? We'll clear the confusion now. So what happens in a core domain is you're trying to solve the business problem, right? That is when you need something that is very robust, something that lets you quickly make changes, more maintainable and more adaptable, right? Because your business changes faster, right? But there are some things that are not going to change much. OAuth, authentication, authorization. These don't give you any competitive advantage. You cannot go and say that unless until you are a OAuth company like Okta or something, right? For Okta, OAuth is a core domain. But for Uber, OAuth is a supporting domain, a generic subdomain, not even a supporting domain, right? And in between these two lies your supporting subdomains. So supporting subdomain is all about, you need it, not so strategically advantage. I cannot use a third party. I mean, I cannot develop it in-house, not so strategic, not so core. I cannot use out of the box solution, not so readily available, like Okta integration for OAuth, right? But something that I need to develop. That is your supporting domain. So this is clear. Core, supporting, and generic, right? Now, all of these within each and everything, within a subdomain or within even a domain, will have some kind of a bounded context. A bounded context is nothing but a boundary that you draw within a system. Say, for example, if you have Amazon shopping app, right? Products, that's a bounded context. In the product context, what is a product? What is a customer in the product context? Shipping is again a different context. But there is also a customer in shipping. What you need to know for a customer in shipping? You need to know the customer's address and details. That's all. And preferred way of shipping. But when it comes to billing, you need to know the customer's billing details, bank account, and other stuff. But you don't need everything of this customer in everything, right? Like what a customer is specific to that particular bounded context, right? Or but that particular subdomain. So that is about all of this. And finally, to tie back to the previous thing, right? One of you asked about how can product owners, I think you asked, product owners, scrum masters who don't have development knowledge or technical knowledge understand what's happening in the project. That's all about this ubiquitous language. That's the language or terminology that you use within a project, within a bounded context. So a term, when I say a customer in the product bounded context, it's only going to have a specific meaning. What are the attributes of the customer for relevant to a product? That might include the past products the customer has purchased. Based on that, how you want to tune your search, how you want to show them sessions, and all of this stuff, right? I'm just going a little bit fast. Okay. So there are a lot more things here, this side, right? I would suggest you to read the blue book, Eric Evans' Domain-Driven Design. I'll give you some tips on how to go about it. So where to use clean architecture? Core domain. Why not use clean architecture for subdomain, generic subdomain, and supporting domain? Because the return on investment is pretty low. Because following clean architecture requires you to do certain things, right? You need to properly follow certain patterns, ensure that your code is properly aligned. I mean, we'll see all of that, how to ensure that, right? But it takes effort. Either clean architecture or hexagonal architecture, or we'll see the difference as well. Onion architecture, these are pretty common, right? All of these three involve considerable amount of effort in terms of writing and maintaining it, making things loosely coupled. Everything comes with a cost. So it's a trade-off. But if you're integrating with a third-party thing like Okta, I can even go with a decoupled layered architecture. That's more than enough. It's pretty straightforward, right? I'm just going to invoke some third-party service. I don't need elaborate, complex architecture for that. So far, so good. Any questions? All right. Next, we'll see the tactical patterns of domain. This most of you would have seen. Entities, things that have identity, value objects, things that don't have identity, right? Services that you write. Again, service can be categorized as application services and domain services. Any domain logic that does not belong to any entity. Let us say I have a method, okay? I want to compute something that does not belong to some specific entity. It's not an entity's responsibility. I'm using 2 or 3 entities to do that. Say, for example, to compute the suggested products, right? I may need the customer's past product history, what he has searched in the past, and his demographics and other details to come up with the session. So I'll probably have a session service to do that, right? That's a domain service. Modules, how to segregate your code, how to separate it. We'll see some examples, okay? Aggregates and aggregate roots. This is very, very important. Aggregate is nothing but, let's say you want to ensure the consistency of your data, the consistency boundary of your data. Let's say a bank account, right? You have a bank account, you have some balance. Let's say you make a purchase. Take it this way. You go to Amazon, you put a lot of items in your basket, then you make a payment. For all these products, it might be coming from different shippers or different delivery on different delivery dates, right? Different shipments even, right? One thing will be delivered tomorrow, one thing will come 2 days after. But all of this, the payment is going to happen in a single transaction. This whole thing is going to be a consistency boundary, right? You need to ensure that the product, of course, there will be different microservices in the background. You'll be sending events to different microservices. They will do their job of ensuring consistency in a distributed system. And they will also ensure that if there is some compensation required, they will also do that. Let's say something goes wrong, you place an order. Am I too fast? Is it okay? Because you have only till 8:10. So if you have too many, what do you call? Let's say the order was placed successfully, but then you find that the inventory does not have enough things to ship, right? At that time, you probably get an email saying, sorry, we took your order, we could not do it. Probably I'll give you a gift card or something to compensate, right? That's a compensating transaction. So that aggregate is going to ensure your consistency boundary. Aggregate root is the entry point. This is the object that will ensure that all the other objects in the background, you cannot, okay, let me give you an example. All of you do cash on delivery, correct? Do you allow the delivery person to take money from your wallet? You own your wallet, right? You will take the money and give it to him. That's aggregate root. You are the aggregate root. The wallet is an object, you are an object. But the delivery person who needs money cannot directly access your wallet. He does it through you. He asks you, give me 200 rupees for this order. You get the product and you give the money. But you own the wallet, right? That's aggregate root. Factories and repositories, more or less straightforward. Does anyone have any question on factory and repository? Repository is for persistence and retrieval. Factory is for creating the same type of object again and again. Predominantly, so these are the 4 areas in your clean architecture: the domain, the application services, the interface adapters, and the frameworks and drivers, right? So these things are going to be mapped in certain areas, right? Say, for example, in domain code, you will have entities, value objects, modules, aggregate and aggregate roots, and factories for creating objects, right? In your application business rules, you will have factories, services, and modules, right? Interface adapters, it's for your persistence and interacting with other services and stuff like that. We'll see examples, don't worry. That's going to be repositories and entities, right? Frameworks and drivers is more of an interaction with the third-party stuff that's outside of your system boundary. We'll discuss that. Okay? So with that, we arrive at the first sleep scale. Let's see who's awake. If you're awake, raise your hand. Okay, good. Thank you so much. I think there are some people who are virtually joining. If you're virtual, leave a thumbs up. Okay. Now, next thing is choosing a business logic pattern. Yeah, I see some thumbs up. Thanks. I don't want to get somebody killed in this session. So, unnecessary karma. Choosing a business logic pattern. The business logic pattern is all about, again, this is from a book called Learning Domain Driven Design, right? What's your subdomain type, right? What is your subdomain type? Is it a core domain or a supporting subdomain? We discussed what is a core domain and what is a supporting subdomain or a generic subdomain, right? If it's a core domain, which is my do or die of the business, right? I'm going to check if I have monetary transactions or analysis or audit log. Are these in my requirements? Do I have monetary transactions like banking transactions? Do I have analysis? I do some analysis with this data. And do I need audit logs for auditing purposes, right? Where you have auditing and compliance related stuff. If that is the case, then you probably need an event source domain model. So event sourcing is a separate topic altogether. That's a term for those who don't know. Go and explore what's event sourcing, right? It's about maintaining the, to put it in simple terms, right? How did I arrive at something? If you maintain just the final state of an object, the state keeps on changing. You keep updating, but how did you arrive at that state? You don't know. In event sourcing, what happens is you maintain the changes that happen. Okay. And then let's say initially I had 200 rupees. I donated 10 rupees. Somebody gave me 20 rupees, right? Now the balance is 210 because 200 minus 10 gives you 190 plus 20 gives you 210. So how did you arrive at that? So if you check your financial statements or bank statements, all of these are event sourced models. Accounts, balance sheets. If anybody has background in accounting domain, your balance sheet is nothing but a, they say, right, accountants use pen. We don't use pencil. Pencil you can rub and write. Pen, one time write. That's it, right? Otherwise, if it is a core domain, without this transactions and stuff, I'm going to use a domain model. That's my business logic pattern. So domain model is nothing but all the tactical patterns, whatever we discussed, entities and stuff like that. So in event sourcing, the same entity state changes will be tracked. So each and every state change to my entity will be tracked, right? What property of the entity, which identity, customer number 1234, location changed from Chennai to Bangalore. That will be captured in event sourcing. But in a domain model, that customer's final location will be there. Bangalore will be there. It will get updated. Mostly, if it is supporting subdomain or if you're integrating with generic subdomain, if you have complex data structures, then you go for active record. This active record is nothing but more like a, I mean, at least as per my understanding, it's more like a ORM kind of a thing, where you maintain whatever record that is persisted, you have a mapping to that. That's the active record, and you keep updating this, and it gets refreshed there. And then transaction script. So all these four patterns, right? You can look into Martin Fowler's book, Patterns of Enterprise Application Architecture. You will find it there. Okay. So far, so good. Okay. We'll go to the next one. Any questions on this? How to pick the business logic pattern? Yeah. Any questions? Transaction script is nothing but it's a olden way of doing things. You used to have a stored procedure that does the heavy lifting. You write some code, a business method or something that does a particular transaction and it moves out. That's it. So it does the entire heavy lifting. That's a transaction script. Okay. So I said you refer to Martin Fowler's book on patterns on enterprise application architecture. That's the book where you can find more details about these patterns. Right. Okay. Let me just take 2 minutes to answer this question. Right. I'll tell you the order in which you can read these books. Probably you start with the gang of four design patterns because that's more like a structural, creational, behavioral patterns at the lowermost level. That's a foundation level, right? That is the interaction between classes and objects and interfaces, how you wire things together, how you create, how it behaves, and how it is structured, right? At the next level, you have the patterns of enterprise application architecture, which is nothing but how to architect things within an application. How are you going to have layers? How are you going to have different stuff that interacts with the database, the business logic, the front end, MVC, MVP, and all this stuff, right? In the next level, you have something called even a book called Enterprise Integration Patterns, which is nothing about integrating applications, because at the lowermost level, you have classes, interface, and stuff, and modules, everything packaged together. The next level, you have application. Within that application, you have layers and components and stuff like that, right? Above that, you have applications interacting with each other. There, you have these integration patterns coming into picture, right? Above this, running all of this in cloud, you have the cloud design patterns and 12-factor app and all those things, system design, everything comes into picture, right? So it's a logical build-up from the lowermost levels of nuts and bolts of classes and interfaces to the highermost level of systems integration. Does it answer your question? Not a straightforward answer. It comes with experience. We'll discuss more after this session. All right. Next one. Choosing an architectural pattern, right? How to choose the appropriate architectural pattern. So that's what I said, right? I spoke about layered architecture. I spoke about onion, hexagonal, ports and adapter, and clean architecture, whatever it is. And CQRS is a different style altogether. We'll discuss that as well. So if this again depends upon my business logic implementation. So if I have multiple persistent models, like I have multiple models to persist, meaning, again, there are systems. Does everyone here know what's a command and what's a query? Okay, can you say what's a command, what's a query? Let's say you are explaining this to a 3-year-old or a 5-year-old, a kid. How will you do it? Do. Right. Do this, get me this. Simple. Right? So do this is command, get me this is query. So if you want to have different models, the problem is this. When you design systems, you always have, are you going to simply keep entering data and saving it? Somebody will read it. Somebody should read it. Otherwise, why are you saving it? Why are you saving the data that you don't need to read? Now the problem is, when you build reports, when you build analytics, if your analytics dashboard and all this stuff, right? Your CEO, CTO, whoever sees the dashboard, they want data that is crunched, analyzed, and everything ready. They want some intelligence out of it. All of this AI, artificial intelligence, everything depends upon data quality. You put garbage in, you will get garbage out, right? Now, this particular data is supposed to have high quality, and when the read happens, it's going to affect your database performance. That is where we separate these reads and writes into two databases. I write into one database, typically commands, whatever I ask to do, whatever OLTP, online transaction processing, whatever you do, operations you do, it gets captured there. And online analytical processing, all this reading, everything happens from a different database. So you have different persistence models. That's what is meant by this term, persistence models, right? So you have a read model and a write model. Okay, that is CQRS. Now from this write database, whatever you write the data, there is some event mechanism or some streaming mechanism to synchronize it to the read model. Again, not so simple. That's where you will have your data engineering pipelines and stuff like that, right? Where you take this data, you cleanse it, massage it, everything put together, and make it ready for analytical model, whatever read model it is, which will be denormalized. This will be normalized, that will be denormalized, right? So that's when you use a CQRS. Otherwise, if your business logic pattern is event source domain model, better go and use CQRS. Yes, it is. That's when you need to know how to do it and when to do it, right? CQRS is not a child's play. Even I have not done CQRS properly. There are a lot of things, right? I mean, you try to see how much you want to do. Say, for example, it all depends upon your business use case, which parts of the system you want to use it. See, that's what I'm saying, right? There is no one architectural style or one architectural pattern that will solve all your problems, all our problems. I am not someone out of you, I'm one among you. All our problems, right? DB replication, okay, not exactly, it is not exactly CQRS, it's probably change data capture. That's different from CQRS. Uh, Probably I'm not aware of that. Write logs, okay, okay. This is more from an application architecture standpoint or application development standpoint. That's more from a data standpoint. It's the nuts and bolts ultimately. Here, what you will do, you will again capture events. You will try to have commands and queries. Commands will write to this database. That will be a different model. This model will have a mapping with the read model, how you want to map the fields from here to there. You also have versioning problems in CQRS. How you're going to handle versioning of your model, because the model version keeps on changing, the event model version keeps changing. How you're going to catch up and do all this stuff. Those are the challenges. So I have quite more to content, so I'll go a little bit faster here, right? If it is going to be active record or transaction script, then probably you have 4 layers or 3 layers of your layered architecture. Presentation, business logic, persistence, or presentation, application, domain, persistence, something like that, right? Okay, I'm just going to the next sleep scale. Everybody okay? Okay, 1, 2, others, 3, 4, 5. Okay, then you are probably in level 2 actually. Next time when you see this, immediately you're putting your hands up. Okay. Okay, I got a thumbs up. Thank you so much. Here comes the finally, then people will thank me. Finally at 7:45, 7:50, you came to clean architecture. I need to do that explanation of the fundamentals to get here to make you understand what it is, because there are a lot of moving parts here, right? And these moving parts, let me tell you one more thing. You go to Google, GitHub, anywhere, do a search. Give me a template for clean architecture. That's the search query. Okay. You will get n different ways of doing clean architecture. There is no one defined way. The reason is the terminology differs. You call the same thing by different names, right? Some people say, for me, everything is infrastructure. I'm interacting with my database, I'm interacting with my message queue, right? For some people, they will say, if I interact with database, that is persistence. If I interact with message queue, that is infrastructure, right? Or if I interact with third-party services, that is infrastructure. That's how they say it, right? So things keep changing in terms of terminology. So how many of you, okay, you can see this, right? I know this, I have used this, I am an expert, I love this, I don't like this. We'll go one by one. I know this. Okay, 1, 2, 3, 4, 5, 6 hands. Okay, I have used this. So probably those who know would have, okay, used it. Okay, I am an expert. Neither am I, don't worry. I love this. I love, I mean, love or like this, actually, there should be a slash here. So, and finally, I don't like this. Those who put your hands up, does anyone, oh, you don't like it? Thank you for not attacking me. Because from the start of this session, I've been talking about this. So I'm sorry, buddy. Okay, we'll have a nice dinner together. Okay, so cool. Yeah, we'll see. We'll see it now. We'll break this down into parts. So the core of the clean architecture, again, there are other things. Okay, let me tell you one more thing. All of this is not AI generated, human created. Okay, so entities, that's the core. The entity is at the center, right? Entities meaning here in clean architecture terminology, it's entities, which includes your value objects, aggregates, aggregate roots, everything. That's what I mapped in the diagram of tactical design patterns, right? All of those things belong to the entities. The next level you have use cases. Use case is nothing but I have business use cases, right? I want to do something, right? Let's say I have a product subdomain. Related use cases are add product, make product obsolete or delete product, right? Add inventory, update inventory, clear? Deprecate product. All of these are different use cases that your business analyst or user comes with. Now, this is where if your BA and project manager and product manager, they have some knowledge, right? By looking at the code in this level and this level, they should be able to make out what's going on, because all of this is going to be plain Java or C# or any programming language. You will not have any dependency on any external frameworks or stuff other than the base class library, right? Because your entities will just typically depend on that. Okay, we'll see this dependency graph, or this is the flow of control, right? So dependency is here. No, they sit on the aggregate roots are entities. Basically, aggregates are nothing but entities. Aggregate roots are the entities. Aggregate is a group of entities and value objects. Aggregate root is the entry point for that aggregate, that entity. That entity is called an aggregate root, right? So let me give you one fun fact. If any of you feel too hard to read that blue book on Eric Evans, right? It took me 17 years to finish. Meaning to understand, observe, feel it, what is going on. Every time I took that book, I never went past 10, 15 pages. Okay. No, that book is much worse than my session. It will make you sleep faster. So, so that is how it is. I mean, all credits to Eric Evans for coming up with this, because in today's age, right, in IT or information systems, everything becomes obsolete. But this concept of domain-driven design, in my opinion, has got much traction after people started understanding it. At that time, when it came out in 2003, 2004, or back in the 2000s, nobody really appreciated, at least in this part of the world. Meaning, many people understood it, but in reality, all of us, the whole world started respecting this after microservices came into picture. Because that when segregating domains, subdomains, everything became a challenge. People hurt themselves by doing microservices first, and then they improved. They learned from the lessons learned. All of this happened, right? The next level is your controllers, gateways, and presenters. Presenters is more for the UI. Controllers are for devices and web, right? That's how you can see it. Gateways mostly for databases, message queues, and stuff like that. That's what you call the gateway. Everything is okay. Let's go to fifth standard again. What is an interface to a fifth standard kid? Anybody? What is an interface? Give a simple. I need to explain a fifth standard boy what is an interface. Okay, we'll go. This plug socket is an interface. Correct. I don't care about the implementation. I don't care about how the power is getting generated. It can be thermal, nuclear, wind, whatever energy it is, right? All I need is 240, I mean, this part of the world, 240 volts, whatever amps, 5 amps, 15 amps, right? That's your electrical specification. This differs across the globe, right? So that is how things are. The nuts and bolts of all of these are interfaces, right? My gateway, my application code will not directly, use case will not directly talk to the database. It will have a gateway or interface in between. So I'll have an interface for the repository. That repository interface will be implemented by a repository implementation. And that repository implementation can be for a specific database. It can be for SQL or NoSQL or whatever it is. No, gateway is nothing but a gateway. It's an entry point. What's a gateway? Gateway of India, entry point, right? Something similar. So the fundamental thing here to understand is there is an interface that is sitting in between this use cases and databases so that there is no tight coupling. If you have one key takeaway, remember interfaces. Then we'll understand clean architecture. We'll see the code as well, right? 755. So the dependencies always flow inwards. It does not go from here to here. That is when I said in the boundaries you have an interface to cut that. That is called dependency inversion. The direction of dependency is this, but from here you have a dependency on this one. You want to persist the data for your use case that you want to implement, right? So you use dependency inversion principle there to invert that dependency. So dependency inversion and dependency injection. Is everybody clear with that, or I'll repeat it once? You want me to repeat once? Okay. So dependency inversion is the direction of dependency gets inverted. In real life, okay, forget the people who do carpentry job because they directly have that wire which they put in the plug socket, right? But you and I don't do it. Every device, okay, how many charging ports do you have in your house? 10 or 5 or 10, much something? Or in a kitchen, we'll take 5. Maximum a kitchen will have 5 ports. How many devices do you have in a kitchen? Oven, toaster, grinder, mixer, fridge, water heater, right? RO system. Now it's 7, okay? Much more sophisticated kitchens. Can you have one socket for each and every device? That's when plug comes into picture. Plug and play. You say plug and play, right? That plug and play is nothing but dependency inversion. The device has a dependency on electricity to run, but the dependency is inverted on the device, which has the plug, which you put in the socket and get the current. Clear? So dependency inversion is that. Dependency injection is more of programmatically how you inject the dependency. Let's say you have a class. This class has a dependency on 3 other classes, and you have a dependency injection framework which injects the dependency. Correct? You get a fever, you go to the doctor, doctor puts an injection because you need the medicine. Dependency injection, right? So the flow of control is typically from the controller. Again, it differs, right? Here you see the implementation, a use case port, a use case interactor, and a use case input port, right? So how the input flows in, probably this is a little bit complex, we'll try to break it down. If you have a microservice, the microservice will receive some events from a third-party service or some other service in your system itself, right? For those you have done microservices. For others, don't worry. You have some incoming request or incoming data into your service, right? And this data goes through your application logic. From your API controller, data comes in, you go through the application logic to do all the computation that you want, and finally you persist the data. So that is your outgoing stuff, right? So that is what is happening here, right? So sometimes it can come from here and end up here, or sometimes it can come from here and go here, where the data comes to your UI, reads and writes and stuff like that, or data flowing through your system into some other system. Clear? I think many people are saying, when is the dinner? Okay, cool. So that is about clean architecture. We'll see an example. Again, it was coined by Robert C. Martin. Onion architecture and hexagonal we'll quickly see in the interest of time. More or less similar, just the terminology differs, right? So there also you have UI, here also you have UI. Additionally, you have test here because my test is going to be dependent on other things, right? Infrastructure, all your persistence, everything is called infrastructure here in the Onion architecture. The application core is nothing but this one: application services, and domain model. We discussed about these things in our previous topics, right? Application services, domain services. Anything that is domain related belongs, anything that's domain related that does not belong to a domain entity goes under domain service, right? Anything that requires orchestration and stuff like that, that probably comes as an application service. Clear? Any questions on this one? So Jeffrey Palermo is your inventor of Onion architecture, right? Application service is more of a, let's say you have an requirement to whatever I told you on that order thing, right? That will be more of an application service. Say for example, you place an order. You have your basket, you have your cart. So I have 3 items in the cart. Now from this, I need to process this order and generate a new order and generate the events for that order. At the same time, I should also notify my shipping service to package and ship this. And not that's a consistency boundary. This is more from a use case or application standpoint. This is the orchestration required here between these things. That can be written as an application service, right? The order service. Okay. That is through events, right? We'll generate events and we'll communicate. We'll not have any tight coupling between microservices. So one of the key aspects of microservices is independent deployability. Anything that breaks independent deployability, you will have nightmares later, not immediately. Okay. If it rains and you go out and play in the rain, you won't get fever immediately. 2-3 days later, it will probably show up, right? Something similar. That's probably you sending your kid to school and the kid bringing some virus home. Cool. So finally, hexagonal architecture. Same thing, same old story, but different. See, all of this is like same stuff packaged differently in different terminology and stuff, right? Application core. Now here is your ports and adapters. This is where that interface and plug and everything will come to picture, right? Adapters are nothing but adapter. Mobile phone charging adapter. No, now nobody gives adapter for any phone. Everybody says cost cutting, eco-friendly and all they say, but they cut the cost basically, right? So adapter is nothing but I'm getting some current in some other frequency and some other voltage. I'm trying to adapt that to this device. and use it, right? Similarly, for message queues or external application, I can have message queue adapter and REST controller, right? For my GUI Windows application web app, I can have web view controller and GUI controllers, right? Now, this is called primary adapters and this is called secondary adapter, or this is called driving and driven, right? The driving adapters are nothing but that's where things originate. You want to do something, that request originates there, right? And driven adapters are something like probably a destination or somewhere where I need to get stuff from, right? So probably if I want to get some get request, get me all the customers who have purchased something between so and so date, starts from here, go through this one, goes through your application code, gets the data from here, massages it, and then gives your whatever DTO response, data transfer object, right? So far so good. When is this session going to end? Yeah, the more understandable. That's it took about more than 1 hour to draw this. Well, I can copy paste, but I don't want to do that. Like drawing makes it more interesting. This is not Figma, it's Excalibur. I'll see if I can do that. Uh, so the messages are coming from here, and you will find this online, don't worry. So messages are coming from here into the message queue. This is some third-party system. I have an incoming queue that I'm listening to. I'm processing those messages through my queue adapter. It's come through this port. Again, this is where you have the dependency inversion. My controller will not directly depend on my application service. My controller will have an application service interface. Any questions? My controller will have an application service interface that it will call, and the implementation of that will be dependency injected. Correct? That's where a pattern called mediator comes into the picture. You don't need to do this, handcraft this. There is a mediator pattern, there is a mediator library for .NET. For other languages also, you have mediator implementations, where a mediator is nothing but, hey, this is the request, who is the handler? Please do this. Okay? And give me the response. That's the job of the mediator. It basically mediates. This is the request that's coming in. Who is the handler? No handler, throw error. I can't do this. Done. Right? So far, so good. Everyone awake? We are nearing the end of the session. Be happy, no? Okay. Sleep scale. Okay, mostly awake. Srihari, good job. Okay. Underlying principles. So, solid. Every interview you go, they will ask, what is solid principle? Or that YouTube, there will be one fellow who's coming. If you don't know solid principles, you are not a developer. Right? No, he's doing his job. Don't, forgive him. Chal. So, these are the underlying principles. You would have heard about them. Solid, I don't need to teach you. Everybody's smiling. Now, so far, serious faces. When I say solid, everybody's smiling. Okay, we'll take away your smile. Package coupling principles. Release, reuse, equivalency principle, common closure principle, common reuse principle. All of these are, this is a session on its own, right? But I'll just give a quick intro for you to go and learn on your own. Whatever gets released together should be, or reused together, should be packaged together into a component, right? Whatever changes together, common closure, whatever changes together should be packaged together. Whatever reused together gets packaged together. Now, the problem here is, and the granule of reuse is your granule of release. That's this principle. Whatever gets reused gets processed, your common reuse. The problem with this is there is always a tension. These keep pulling your architecture in opposite directions, right? For a developer, during the early days, you want to maximize your build time. Minimize your build time. So you put everything in one project and seal it and build it and deploy it. Much faster, right? When you go to production, you try to minimize your update package size, right? So during the earlier phase of a project, architects need to favor packaging things together for build and development. As the project goes, you need to refactor your system such that it's much easier to deploy and provide updates, right? This comes with experience. Read more about this. If you have more questions, I'm on LinkedIn, you can reach out. Next, package cohesion. This package coupling. Okay, I think there is a small typo here. This should have been package cohesion and this should be coupling. Okay, sorry for the typo. So acyclic dependency. There should be no cyclic dependencies in your this one. You will not even build. Why are you talking about these principles? IDEs now will take care of it. No. Back in 2003, when you had Visual Studio 2003, it will not work like that. You can add project references directly and then finally the build will break when you clean the system. When you do a clean build and then rebuild, it will break. Right? Because I come from an age where you don't have rename facility in Visual Studio. Yeah. Stable dependency is nothing but you depend on the direction of stability. Whatever is more stable, you depend on that. And finally, stable abstractions, whatever is more abstract. You put your interface and everything together and you depend on the interface package. Right? Read about this. Definitely, it's a good read. Now, architectural fitness functions. Okay, you gave a lecture for 1 hour and 10 minutes on clean architecture. I will go and do all this in my project. Some of my developer comes who don't like this, or probably he doesn't like me. He will just go and screw up this code base. What will you do? Mess up, whatever. Right. So, what will you do? That is when you have architectural fitness functions, where you can write code which tests your architecture. Okay, so we'll see a code example for that. Right. With that, I think this is the next sleep scale. I'll use this after I show the code. Okay. So we'll quickly jump into this one and complete in 2-3 minutes. I was given 8:10 as the deadline. So what's going on here? So this company.product.subdomain.microservice, typical naming convention of any .NET project where you have this. For those who are not from the .NET world, forgive me. Same thing you can do it in Java, right? Reverse com.org.whatever. Right? So what is going to happen here is I have the source and the test folder. In the source, I have application, domain, infrastructure, persistence in web API. In my test, I have architectural test and unit test. Right? Follow test-driven development. I have not written any major code here. It's just a template that I created for the session. But we'll jump into the architectural session. So in the architectural fitness function, I have something called as a dependency test. Now, net arc test. Note this down. Net arc test. That is the library for .NET that provides you ability to test your design and architecture. Okay. For Java, it is arc unit, like JUnit, arc unit. Easy to remember, right? Is the code visible, or you want to zoom in a bit? Net arc test for .NET and arc unit for Java. Okay, so we'll go to view, appearance. Zoom should be something that is readily doable. Somehow it doesn't work. Okay, is the code readable, visible? Okay, nice idea. But where is the presentation mode? I have not used it. No. Double shift. EPT. Sorry. What is it? Mm. Okay, cool. Probably I would have pulled out that window and maximized it. Cool. Thanks for sharing. I didn't know that. See, not everyone should know everything. If your team knows everything together, you are good. And it's good to have people who know things with you. So try to associate with good people who know things. So, this is nothing but an outline of a test. I'm saying namespace in the domain should not depend on namespace like persistent infrastructure application, right? And then I assert it. If it is successful, then it will not have any problem. This test will pass, right? Like this, we have written a series of tests. My controller should not depend on this. My controller should depend only on this. My domain should not depend on anything. My persistence should not depend on this side. You ensure that you put all the permutation combination as test, right? And then when you integrate this with your CI/CD, it runs like your unit test. So the developer will get a failure right away. When he runs the test in his local machine, will see a failure. Okay, want to see a failure? Now how to come back out of this mode? Okay. Okay, cool. Thank you so much. It understood my pain. Okay. So to fail this, we also have naming test, right? So naming tests are nothing but I can name, I want to, all my controllers should end with the name controller. All my repository classes should end with the name repository, right? So that is the naming convention. I'm just giving examples, right? All my command handlers should end with handler. All my query handlers should end with handler, stuff like that. Or all the classes in this namespace should be ending with this name. All the interface should start with I in C Sharp, not in Java, right? So all of this can be written as tests. And there are numerous samples online. Don't worry about the code. There are numerous samples online. And I'll tell you the source where you find all of this, right? So if you want to, let's say you want to fail this test, right? I go to my, I'll go to my persistence, I'll go to my repositories folder, okay, and I'll just say add a class, and I'll put a class, okay, some test. It should be test repository. I'm just putting it as test, okay. Now I run this test. Again, I did not do it before the session. Hopefully it should work. It should fail. Failing is easy, no, however it will fail. Failed. Something failed. Still building. Everybody is equal to see the failure. Wait, no. Okay, still running. Wow, awesome. Then probably something is wrong. Cool. I'll probably fix that later. But that's the idea. If I have this in place, right? It should be in naming test. Dependency. Where is my? Sorry, my Zoom. My Zoom is actually hiding this file. Yeah, ending with repositories. Right. Cool. I'll probably look into this, but you got the idea, right? If your developer or somebody does something that does not follow your architectural guidelines, your test will fail and indicate it. Okay, cool. So with that, we are close to the end of this session, right? All good? Okay. Few of you forgot the protocol. Okay, good. Cool. Books. Clean architecture. The name goes with it easily. You can find this book and read it. This is the book written in 2003, 2004, but it's still relevant. But when you're reading, you need to relate to the current developments in the industry in terms of platforms, frameworks, and programming languages, right? Get your hands dirty on Clean Architecture by Tom is another book. And then you have Implementing Domain-Driven Design by Vaughan Vernon. And then Learning Domain-Driven Design, this monkey book by Vlad Kononov. So this monkey book is something that's easy to read to start with. I would say start with this, then go to the blue book, and then finally end with implementing DDD. Okay. So that concludes this session. I'll stop sharing now. Any questions? How do I understand? No, I don't know everything. When somebody speaks about something, you should not think that they know it. It comes with time. Time is the best healer. Any other comments? Any other questions? Hope you got something out of this session. Did you? Or was it another information overload? Already we have Instagram Reels, YouTube Shorts. The problem is with this kind of a topic, right? The only challenge is to engage people. Unfortunately, as humankind and mankind, our focus has reduced to 15 seconds and 30 seconds for shorts and reels, right? I hope this session was engaging. You got something out of it. Thanks for listening patiently and investing your time in this. Thank you so much.